graduated in civil engineering in 2013. I used to be at this lab called Intelligent Transportation Systems Laboratory. If you don't know what that is, what that even means, we built this bus tracking application for IIT Madras back in 2012. It doesn't function now, but if you ever want to revive it, please go to this lab. You can do some amazing stuff. So after that, currently I am part of a lot of open source communities in India. I'm part of a lot of open source communities in India, and I run a startup called OpenStats. It's a startup focused on open data. So I'm kind of an interdisciplinary researcher. I focus on cities, data, and internet. Part of data and internet, I focus on cybersecurity as well and privacy. So I write a lot about this. Whatever I do, it's on my blog. I usually write for the media as well. If there is a major hack which is out there, I usually write about it, at least document it. So today I'm going to just cover basics about the Android architecture and how you can look into the security vulnerabilities and pen test Android applications. Okay, be good to go. Don't forget about your installations if you don't have the software installed. Okay, at this point I don't think it makes sense as well because there's so many people and most of you are not on the right OS to actually go forward. So oh yeah. So did you guys try opening the APK file? Download any APK file on the web and try converting the APK into a zip file and open it. Did you try doing that? If not, you try doing it. So what you're going to get is you're going to basically get, sorry. You'll see that there is a couple of packaged items and you'll find a couple of DEX files. If you don't know where to download an APK, you could just look at this tool called APK Downloader and give it a Play Store path and it'll download one for you. Which one do you want? WhatsApp. So okay, so you can just convert the .apk into a .zip file and you can just open it. You'll find a couple of interesting class files. Sorry. Yeah. I'm slightly on a bad resolution here. Sorry for that. See the WhatsApp APK over there. You can just copy that into, say, app.zip. So what I have now is I have here two files. App.zip is a copy of APK file, and I'm just trying to unzip it. And you have what you have is assets folder, classes.dex. You got a lib, you got a meta-inf, you got resources. You got a couple of other tools which are packaged into this APK. So if you ever try developing for Android, developing an Android app, this is how your project structure looks like. You have a resolutions folder where you put in your images. You have layouts folders where all of your Android screen layouts go, and you have your source code. So all of this is packaged into your .apk file, and all of your Java code becomes classes.dex. So Android has something called Android runs on something called Dalvik Virtual Machine. So all the Java code gets converted into .dex file, which internally runs on this virtual machine. Android has moved away from Dalvik Virtual Machine into something called ART, which is Android Runtime Machine, from Android 4.4 or 5. So even now it's .dex, but in future you won't find this. The Dalvik Virtual Machine is being removed. I mean, the project is not going to be supported soon. So Android has this, every OS upgrade you get, the architecture of the applications change, the way you code changes. The similar way how every Java version, for example, if you're using Java 8, if you have compiled your code on Java 6, it won't run on Java 8. So you have those compatibility issues similar with Java, which comes as that legacy issues to Android as well. So now that you know what and how the Android app structure is, if you're running an app, this phone, right? There's a lot of apps which are running in the background. How many of you know that every 10 seconds your location is shared with Google? You know that? Sorry? You can. So you have something called location history, and you can disable it. But even then, how many of you here know about the permission structure of Android? How permissions are set in Android? Not really familiar, right? So when you install an app, sure. So okay, I'm going to come there. When you install an app, the app asks you permissions for a certain layer. So the reason it happens is each app is isolated. So when you, in your phone, no app can access a different app's data. So each of them are sandboxed. So each of them has these rules, which are from, again, Linux's permission setup. Android borrows its architecture from Linux because of its architecture, the way it's based on. So each app, each sandbox needs to ask this Android OS for permissions that, look, I need permission to access your camera. I need permission to access your location. I need permissions for various different things. So these are coded in something called a manifest file when you develop the Android app. Okay? So the problem is the multiple issues with the permission layer of the Android structure. If you've ever used with iOS, for every time you wanna use something, the phone asks you that to allow, should this app have access to your camera? You can deny it. But that was not the case with Android until Android 7. So this has been misused a lot. From a security perspective, it's a total disaster. It has been a nightmare. But why is this important? Because if you know that each app is accessing these permissions, that means this app is accessing so much of this data from you. And most of the times, every app has access to internet because the app communicates with its app servers to send in data and receive data. How many of you here know how the internet works? Or for example, how HTTP works rather, and how DNS works? Please show of hands if you really know about it, and if you don't, then just say no, a big no. No, right? Okay. So just open your browser and type google.com. And did you ever use Chrome debug tools? F12, if you just press F12 or press right click and you get inspect tools, just do that and choose the network tab. You have a whole list of tabs on your Chrome browser. So and open Google. So what it shows you that when you type Google, when you go to the Google server,
web page, you'll see that there are a lot of requests being made to a particular server, and you'll see the type of request and the response code. It usually is a GET request, and you get a response code of 200, which is the standard response code that the server has sent its response that everything is fine. If there is an error, you see something called 404. Have found that 404, the file is missing. So these are standard HTTP codes that something is right or something is not right. Do you guys do that? Did you try the Chrome developer tools? You need to either press F12 or right click and inspect element and open google.com or any other website. Okay. So what's happening here is when you make a request, when your browser is you're entering something in your browser, facebook.com, Google, or any other website, the browser makes a request to a server located somewhere else that, look, I need the web page which is hosted for google.com. So what happens now is, what is google.com? Instead of google.com, if you had an IP, have you ever accessed IP-based servers in any of your student servers? I believe you should have. So google.com is a domain, and this domain basically points out to an IP of a server, which is usually a set of numbers. You're opening one? Okay.
Hello.
Yeah. So even you'll get that IP when you're looking at the developers tools. When you're looking at the network, you also get this IP of google.com. What happens is when you enter a domain, it basically translates to an IP that this browser needs to get data from this particular IP. The way it happens is google.com makes a request to a name server of .com name servers. Internet has an architecture where domain names are registered with registrars, for example, GoDaddy, where google.com probably is there. And when you make a request, GoDaddy's name servers will go check the .com servers to give Google's IP back to your browser. When that doesn't exist in a particular server, it goes and asks a different server. So all of this is connected.
So the ISP points to
So the multiple points here. So when you make a request in your browser, it goes through your Wi-Fi router here, and from your Wi-Fi router, it goes to the IITM's router, main router, through them to the telecom router. Then that goes to a different name server, which then identifies that, look, I don't know where google.com is. Why don't you ask a different name server, which is .com? If it's .in, it's probably in a different server. If it's .org, it's in a different server. Each domain name extensions have its own servers because there are millions of these domains. Multiples of .com domains are multiples of .in. So all of these exchange information, and you ultimately go to this DNS server which has the google.com's IP in its DNS settings, which is domain name server. Domain name is basically google.com, and the domain name server has google.com's IP. So there are a lot of points where your request passes through, and you get back your request. Similarly, when you make a request from your Android phone, it goes through all of this process, and you receive the data. Okay? So now, how many of you know what a proxy is? Proxy? Ever used this, ever set this up in your labs? Okay. If you again have Chrome or Mozilla, you have in your preferences and settings something called proxy. So what happens is, like IIT Madras, when you're in a closed work session or an academic institution, you want to control the traffic information flowing from your institution to outside. So before you moved on to net access, we used to have something called a proxy, where every server which needs to access the internet should go through a different, one more third-party server called a proxy server of IIT Madras. You would configure your browsers to go to this server first, and this server would connect you to the internet. Okay? So the same way that to access internet, you probably have to go through a different proxy depending on the restrictions. you can also use this proxy to set your laptop as a proxy. So, for example, if your app is making requests, instead of the request being directly going to the server, you can route your app request through your laptop. Are you getting at this? Do you have any issues with this idea? And right, I'll show you how it's done. But the idea of the proxy is you have a middle man in the middle who is intercepting your requests. So the tool which I sent you, the man in the middle proxy, MITM proxy, is basically from an age-old idea. How many of you heard about Julius Caesar? Julius Caesar, yes, right. Do you know that he has a cipher named after him? How many of you actually know cipher, what a cipher is? Yeah, so please tell me what a Caesarean cipher is. Simple words, it's pretty simple.
It's a code done by Caesar to communicate between camps.
Louder, actually.
It's a code done by Caesar to communicate between his camps. So even if it falls into enemy hands, they won't know what they're doing.
Yeah, so what Caesar did back in those days was, if he had to communicate with the general, saying that, look, attack this country, he wouldn't simply write it in plain English words. He would just jumble the words. So A becomes B, B becomes E. He used to shift them by 3 numbers. So if you have learned number theory, this is what is used to break ciphers. This evolved over time, and this was one of the first early ciphers. So even if somebody intercepts this gibberish message, they would not know whether these numbers were shifted by 3, by 4, by 5, by 10. Caesar used to use 3 letters, as I said. For A, it used to be D. Okay, so you could just write down a message, replace each character, and you'll have an encrypted message. But this form of encryption is called symmetric encryption. You encrypt it, and you can also decrypt it if you know the key, and you don't need an extra message, right? You don't need an extra key. So for example, you can lock it, and you can also unlock it with the same key. But over the years, people realized that these forms of keys are vulnerable, and they said, look, we'll get 2 keys for a lock, one to lock it, one to unlock it. This is what RSA, or your public-private key encryption, is. And if you're trying to send emails if you're trying emails to somebody, what happens is Gmail encrypts it with your private key, with the other guy's private key, and he can, public key, and he can decrypt it with his private key. There are 2 keys, basically, one to lock and one to unlock it. So the idea for all of this encryption is, if somebody intercepts it, he should not be able to break it. So now what you're going to do now is, we're going to intercept traffic from your Android phone. So if you have MITM running, all you need to do is just type MITM proxy, and oops, yeah. Sorry, I'm just searching for. I don't know what happened. Sorry, that was an issue. Right, so this is just an outline. So this is running on my port 8080. What I need to do now is reroute my phone traffic to this port, this IP. How I can do that is basically be on the same network, connect my phone to the Wi-Fi, and also make sure that the laptop is in the same Wi-Fi. And in your Wi-Fi settings, you have something called advanced settings. Just go have a look, and you can set up something called proxy over there. Can you help me with this? Just, it's wet. You can have a look. For now, it's this. Okay. Until here, it's wet. Okay, so how many of you know what an IP is again? Because when I say I have to reroute traffic through my laptop, right? I need to make sure it's only going through my machine, not somebody else's. So each machine has a unique ID, on the internet called the IP. Okay, the Internet Protocol address, the IP address. You're aware of this, right? Okay, so if you want to know what your IP address is, you just type something called ifconfig on Linux, and if you want to know it on your Windows machines, you type something called ipconfig. Okay, and you will get your, sorry. So you will have multiple, yeah. So you'll have multiple routers. For example, if you have a LAN wire, then it will have an ID. So say if you're also connected to LAN wire, Wi-Fi, you're also connected to your phone SIM network, there might be multiple layers of IPs for each of them. Okay, so you need to make sure that you know the one which you need for this router, which is, yeah, this. So WLP is the ID of this Wi-Fi router, and the internet address, the IP address for this laptop is 10.21.170.138. So I need to configure in my phone this IP address in your Wi-Fi settings. Just long click on your Wi-Fi address in the Wi-Fi you connected to, and you have advanced options where you can configure this along with the port. You did that? Yeah. So the moment he does that and he opens any apps, 10.21.171.138. So if your MITM is working, please do this. And if you have somebody else who has one, please have a look into their laptops as well if you want to try doing this. Yeah. None? Open some apps. Oh, you need to connect to this. Where did you connect? Yeah. Yeah. See that request? He made some request, he typed something, and I can intercept it. It's exactly like your Chrome developer tools, but in this case, you would know what every app is communicating to. Every request which goes to my app comes here. Yeah. Yeah, do that as well. You can also connect to the same server. In fact, if you want to do this, if you configure your phones to this particular proxy, I can intercept your messages. You want to try doing that? Any one of you want to try configuring your Wi-Fi to this?
Only if you test WhatsApp.
Yeah, so don't worry, but you'll just see what's happening. So ideally, what happens here is I'm able to only intercept HTTP request. You see there's no HTTPS request because the way HTTPS works is it's a secure connection, so it verifies the certificates, the encryption keys, that look, I will not send this request unless you authenticate yourself. But in case of a normal request, when there is no authentication, anybody can intercept this. That's one of the reasons why everybody wants you to use only HTTPS websites. So if you look at many of those websites like google.com, facebook.com, they're usually only HTTPS only. They don't work on HTTP anymore because they're easy to intercept, and I don't know if somebody else connected, so there are more requests. Yeah. Okay. So yes, IIT can actually track what you watch, what you download every day. Okay, because you're in a closed network. So
the logs I have seen, every username, what website they are visiting, when they visited, how much data they downloaded, everything is logged in the center. I just output 6 GB of data with these logs every day. So nobody is looking at it unless there is a suspicion or a reason to look at it.
Questions are welcome. Even then, it goes through a request. It doesn't matter. Incognito is a feature where browser doesn't track you, not the server.
So if I just show you one example. So let's say if you go to google.com, as I shown here, this is how it reaches to Google. It goes to Huh?
Did it trace route?
Yeah.
Okay. Yeah.
So it goes to these 10 steps, and look at the first step where it is. The gateway is in computer center. This 1021, 171, 254. This one is sitting in computer center, monitoring everything you are doing. Every request that goes through it is monitored. Even this is exactly the firewall IP. This is the firewall. So everything goes through the computer center to wherever the next hub is, and like that, at the end, on the 10th step only, it reaches Google. So now it comes back all the way to your system with the data.
Anybody at this layer can track what you're doing.
Only HTTP, by the way. If it is HTTPS,
It's usually secure.
Yeah.
Usually, even they can be manipulated. Okay, so MITM has this feature, right? So it's not just intercepting about HTTP requests. It can also intercept HTTPS requests. But for that, what you need to do is you basically need to, yeah. So when you install it, creates a hidden file. Sorry, yeah. Yeah. It creates a hidden folder called MITM proxy with certificates when you install it on a normal Linux environment. Also on Windows environments, I'm not sure where it is, but you have certificates. These are basically HTTP certificates, which if you install in your own phone and ask that to trust the certificate. So what happens, the way HTTPS works is, when you go to google.com, you get a good green symbol which says trust this website, that this is original google.com. This has been trusted by somebody. Who is this somebody? We have something called certifying authorities. For example, VeriSign is a very famous certifying authority. So is GoDaddy. They issue certificates to websites and say, look, I'm a trusted party. I'm issuing a certificate to this guy. Like the same way IIT Madras issues a graduation certificate, there are certificate authorities which issue these certificates. Have you ever recently tried visiting some of the Indian government websites and faced that, look, this website is compromised, this doesn't look trustworthy? Have you ever faced that? So that's because Google said, look, Indian government, we don't trust you anymore. You started, Indian government issued fake certificates for google.com recently, about a year or two ago. So Google said, from now on, we are going to remove these certificates from Chrome. Every time somebody visits these websites through Chrome, we will show them a warning. Okay, so in your phone, these certificates are pre-installed. Like in your desktops, laptops, everywhere, VeriSign says that it has these trusted credentials which are pre-installed, either in OS or in the browser. Chrome has some of them within itself. The OS, Windows could have some of them. Android has some of them on your security tab. If you go look your security settings, you have something called trusted credentials. You find them, just go to security, settings, security, and you'll find them credential storage type, trusted credentials. Just click on trusted credentials and you'll find various list of certifying authorities. You'll find VeriSign, you'll find GoDaddy. At the end, check, just go down, you'll find Visa. So what the phone knows is that these are pre-trusted authorities, you can trust them. The way you can trust all of the IITs, that these are legitimate institutions. If they are giving you a certificate, they're good. So here, if you're installing your own certificate, so there is a user tab as well. You'll have something called a system tab and a user tab on your right after that. The user tab, you can install your own personal certificates and say, look, trust this certificate. So if you, as I said, you might receive warnings, right? You probably have received some of them while visiting few websites on Mozilla. Then you say, look, no, trust this website. When you click that, Mozilla basically installs in itself that certificate saying that I will trust this website from now on. So if you do that with MITM proxy, you can even intercept HTTPS requests. The moment you are able to intercept these requests, most apps do not encrypt data. It's a fact that Indian developers who are young college kids who want to be millionaires, they do not have the idea entirely about how to make an app. They simply make an app and they just send it out. Most government apps, most new apps are usually not secure because the moment you're entering your payment card details or your personal details, phone numbers, all of them are passing over HTTP. Or even with HTTPS, their APIs are probably public. So, no, it's okay. Sorry. Yeah. Have you recently heard about the Modi app hack? Have you heard about them? No one? Oh man, you guys don't read news, do you? Okay, so the Prime Minister, the Honorable Prime Minister, after demonetization after November 8, he wanted to understand how people are viewing about his policy on demonetization. He just made a tweet asking everybody to register on his personal app, which is the Namo app, and give feedback to him. There are about 7 million people which registered and gave feedback to the Prime Minister. And I believe this from the numbers which reported in newspapers and which BJP and PMO's office released. I'm not really sure. 7 million citizens have gave feedback to find out with the app. The problem was this app was using basic APIs with no restrictions, no authentications. For example, when I take this request, right? So if I copy this request, so you get much other information when you're intercepting that. So if you click on those, you get what your request was. Your request was made from a Mozilla client on Android and the response you get. So you have detailed information. So usually when your app requests, you get response. In the response, you get that, look, somebody has messaged you and this is the message he sent you. If it's not encrypted, it will be shown in the response. So the Prime Minister's app was communicating this way. They were giving out responses in a very open way. They're not encrypting, and they were giving out phone numbers and as well as email IDs of everybody. I kind of documented that. No, I mean, I did not disclose it. This was disclosed by a young kid, a 22-year-old programmer, who was not sure what to do. He found that. So if you go back and if you intercept your apps now, you will probably find some other vulnerability somewhere. If you really know where and what to make the request, you can write a small web crawler in Python to get all the data dump of every individual of that app. So this young programmer, what he did not know how to disclose it. What do you do when you find a vulnerability? Do you misuse it? Do you report it? Do you make profit out of it? Profit? Come on. Oh, sorry. Right, this is it. Yeah. So.
Is it feeling hot?
Yeah.
We're gonna move to the other room. Let's take the messy problem. Huh?
No.
No? It's fine? Is it interesting? Okay. Fine with that.
Sure. Because I'm sweating like you.
We do.
I can't stand you. We'll move to it quickly. 5 minutes. Huh? Close the laptop, grab it, go there and sit.
Don't worry. I will be here. I'll be here tomorrow too.
No,
Let's move. Yeah.
we're all going.
Yeah.
Hey, 1 second, guys. Wait.
1 second. So, hey, I'll show you this until he comes back.
Guys, wait.
Yeah.
Take a rest. Back to move.
Okay.
Sorry for the trouble.
So this young programmer, he found that I found a security issue on the app, and he just tweeted to Modi. Like, he didn't know what to do. So, and there was no response. So he went and gave it out to a publication called Your Story. I believe you are aware of it. Are you? Your Story is a startup news, online news media organization which writes about startups. So they just ran a story while the issue was public. While the security issue was public, they just ran a story saying that, look, the Prime Minister's app basically gives out contact numbers, gives out date of birth, email IDs, usernames of every individual who is on the app. Huh? Yeah, that was for Smriti Irani. So the app itself was designed as a social media platform. Okay, so the same way when you search for somebody on Facebook, you could search on the app and you would get that somebody's information. Even though they were not showing that phone number on your screen, the request which was being made to the server, the response would have it. Okay, until you look under the hood, you don't know. Okay, so this guy found it. This is not a serious security issue. It's a known issue. See, when I say that if the APIs are open, anybody will know it. Anybody can intercept it. The guys who designed it didn't care about it, didn't knew about it probably. So this happened. And if you're actually doing some of these testings to identify how your phone is communicating with op, you will find these things. And it's important to know that when you find these things, that you be responsible and report them. Unfortunately, there are no right reporting methods if you have to report it to the government. I'll come to that at the end. But if it's a private application, what you could least do is you'll find the developer's email on your Play Store. If you go to the Play Store, at this bottom settings, you will find the email at here probably. Right. Here, visit website, email, privacy policy. Shoot them a mail usually. But better thing to do is they have something called bug bounty programs. So what a bug bounty program is, I'm Google or Facebook or any of these companies. I'll tell, hey, I care a lot about my security. If you find vulnerabilities in my security, my servers, any of my infrastructure, if you tell me, I'll pay you. But the way it works is you can't make this bug public before you report to them. If you do that, they won't pay you. The way it works is you go send them a mail saying that I found this issue. And if they can replicate it, they will pay you. After a period of time when they verify it and they fix it, the amount of money could range between $100 to $10,000. Okay, so it's huge. So HackerOne is this crowd. It's a website, it's a platform for hackers where you can register, and there are a lot of bug bounty programs where the company is saying that you can hack us in a responsible way and report us and we will pay you money. There are few Indian companies like Ola, Paytm, Zomato listed on HackerOne. If you find issues with them, you can actually report it through the platform and they'll pay you, if it's a serious bug. At the end of all of this, you can blog about it, not when the bug is open. Do not release that this bug is open to people, because the moment you publish anywhere on the web, people like me will probably misuse it. So that's not what happened with the Namo hack as well. When it was published, they were clueless that this was happening. The developers were clueless and others were able to access those APIs briefly. So after the report was made public, I rechecked what was the issue. I just checked their APIs. They made a quick fix. What they did is, for email, they said xyz@xyz.com. And for phone number, contact number, they replaced it with 10 zeros. So they immediately made a quick fix. I'm not sure how it is right now. You can go and check later. They probably have encrypted it, but ideally this whole message needs to be encrypted. If you look at the communications, what's happening with WhatsApp, Google, or Facebook, they usually encrypted. And it's not easy to crack them. Okay, there are various forms of encryption. I really don't want to get into it right now. But ideally, this message should be gibberish. When you look with the naked eye, you're not supposed to make sense out of this. Okay, so this is some early issues which you will find. If it's an app is new, this is something you'll find. Okay, that's pretty much about how you intercept APIs and how you try to find out what is it that your app communicating with each of these servers. And when you look at it, you'll find that Facebook is collecting information every time you open an app. Every time you open an app, if the app has a Facebook login with the Facebook SDK into the app, they're collecting user analytics. Google is probably collecting information. If you have a Xiaomi phone, they are probably collecting your location data with servers in China. Okay, you got any questions until here? It's pretty straightforward for you. So now, what if your communications are encrypted, right? This is like the first layer you're checking. What is it that your app is doing? But this is only at the network layer that you know that these actions are happening. You can also try to check at the source code level of the app, what is it the app designed to do? So you got the APK, right? So once you have the APK, you can decompile the APK because the APK holds all of the tasks it needs to perform in an Android application. You can simply look at the source code or the decompiled code of this APK, and if you understand the language. So in this case, it's being decompiled to Java. If you're very familiar with Java and Android architecture, if you have designed enough applications to know that, okay, this class does this, and this is what the app is doing. By reading the source code, you can understand what the app is doing. So when you're talking about encryption, you'll know that the encryption, the app is encrypting content from the app side, right? That's the client side. So if you can break the client and try to identify how it's encrypting and decrypting. So when you're sending messages to somebody through WhatsApp, you're also receiving it. That means somewhere the encryption is being decrypted, right? You're also encrypting it to send. You're also decrypting once you receive. So on the app, somewhere these functions are happening. So if you look at the source code, if you find this, you can estimate what and how they are doing this. So the best way to do it is decompile applications. Sorry. Yes. So I'm running this tool called the sorry. Just running this. Sorry about this. So the multiple tools to decompile an application, right? So this is not a new thing. People used to decompile Java code. The Android just came way later. Java has always been there. So when you write your Java code, what the Java compiler does is it basically compiles it into .class files for the Java virtual machine to run. As I said, what's happening here is Java is being compiled into .dex files for Dalvik virtual machine to run. So you have multiple decompiler tools which basically can decompile applications for you. There are others for Java as well. This is an application which called JDX, which decompiles the app directly from its source to give you the Java code. So we downloaded the WhatsApp APK right here. So we can just open the app through the GUI, or you can use the command line tools, and the tool would basically start decompiling it. And here you go. You're getting the source code. Are you able to see this? So in an Android app, you use several of other third-party services. For example, if you have to integrate Google Maps, you'll be using Google's tools. If you want to integrate any other third parties from Facebook's own SDKs, or say WhatsApp is allowing you to communicate through WhatsApp from your app, you can integrate it. So your entire APK, the code has all of these tools as well, their own code as well. So if you're seeing this, you're also seeing basically other libraries like Android support. So Android support code is out there, out open. The core WhatsApp code would be probably in Orc. Oh, okay. So the Whisper systems you see here, this is basically the WhatsApp's encryption code. The reason I know about this is because there is a popular app called Signal, which is designed by Whisper Systems, whose encryption structure is what used by WhatsApp. Okay, so if you go open it up, you'll find its source code, but actually most of this code is pretty much open as well. So for any other application, you could just open the class files. Sorry. You will find the code. So of each Java file, the multiple files, it's not directly straightforward that you read the app without understanding how the Android app source code usually is. If you have developed some applications, you would know that what to look for. Hey, look, this is where the app is starting. This is where usually the network request is being made, or this is where they are encrypting this code. So it's basically linked, and you can read the source code, and you can estimate that this is what is happening in your Android app. It's not straightforward. So what people do is, because they know that this can be done, it's not like they're not aware, Facebook or Google or any other company is not aware that you can decompile source code. They obfuscate the code. So when you're writing the code, when you're compiling it, you add some gibberish code which does nothing, right? So you confuse the compiler to add extra lines of code. You can hide some of these elements for a decompiler to confuse decompilers. I'm not really someone who is working on decompilers and compilers like code. This is something you should know. If you're in CS, you'll probably learn about compiler systems somewhere in your 5th or 6th semesters. Maybe you should look into that then. So there are ways you can obfuscate your source code, and these agencies, these companies do that. There are also these private tools which can make it very complicated. They can start encrypting the entire source code itself, but make sure that Android is able to run it at the end. You got this? Are there any issues with this part? So if there is a new app or a nascent app, which is probably not using security, it's pretty much easy to identify what they're doing through their source code. So each of these are methods which goes on higher and higher in complexity. Like if you've seen, the easiest one would be to just intercept what they are making, what requests they are making. Once that is encrypted, the next layer is look at the source code. Even that is there, you probably have to write your own code to desimplify it. It's not, the tools are not going to help you always. Tools are just there probably to ease your tasks. They're not straightforward to tell you that, hey, look, this is where the security issue is. But there are popular tools which kind of do this security analysis by itself and tell you what issues there are. But yeah, these are some of these tools. Any questions here? Or is it going yet over head? Am I simple enough? Did you try running this? I think some of you have this, right? Some of you have installed JDX, and you could probably try downloading an app and try opening it.
With all the apps that are given the network request, or it is with also the standalone app like CamSnap app. It's standalone app. It doesn't have to do with anything.
The question is it communicating over the network?
Yes.
It probably not. It's probably not. You don't know, but if it has ads, it probably is. So you don't know until you look into it, until you look at the source code. You really don't know what an app is. So if you're talking about from a privacy perspective, where are the issues? If an app is standalone, if your cell phone is not connected to the internet, nobody's spying on you, because you cannot reach anybody and nobody can reach you. They're just out there in the middle of nowhere. Okay, so it's safe, but that's not how it works. There are a lot of apps, and most of them always communicate. The idea of this whole cloud makes it everybody to collect user statistics. Even for CamScanner, they really want to know how many times you're opening that app. So it's rarely the case where somebody is not collecting any information from you. So the reason this is important is it's not just about from a security perspective, it's also from a learning perspective. For example, you're just learning Android. You should see this cool app which is doing something beautiful, so you really don't know how to do it. You can decompile their app and try to understand what's happening. So you can look at an internals of a third-party application to understand what is it can do. But this is not the way to learn things. Ideally, you need to understand a lot of these systems. You need to independently understand how Android works, how Linux works, how you develop apps. Once you're done, once you master these skill sets, then this becomes much easier. So there's nothing called hacking. All you're doing is you're checking for loopholes. So if you're, the whole idea that you need to know this is once you're developing your own app, you actually do all of this and try to see that your app is vulnerable. It's important that you do this because legally speaking, if your customer can sue you for invading his privacy, for not securing his data. So if you corrupt my data and you mess up, I can file a lawsuit against you and demand that you compensate me for the loss you have done. For example, if they're storing your bank account details, right? When you're giving out your banking details in your apps, for example, you're ordering food or you're doing something else, recharging your Paytm. If that gets out, that's a serious liability, financial liability for you. So you can actually sue these companies' apps for that. So if you're ever making one of these apps, you need to be very careful about these as well. And that's why it's very important to understand how it works. Unless you understand the entire core architectures of it, you cannot just say I built an app. It's not that simple. It's good. It's a good start, but apps don't solve everything by themselves. Okay. Any questions? I was hoping it would be more interactive. You want to do some of these stuff in popular apps? You want to check, download some of them and do it? You guys want to try doing that? Should I stop this, or do you want to do that, or do you want me to go more about it? What is it that you want to do? Sorry? You want me to tell you more?
Yes.
So one more thing which you can do is basically, assuming that you read the source code, what now? Say there is a paid application, for example, a paid game, which would not allow you to use the game unless you pay for it. Can you just remove this particular part of the code where it asks me to pay money and recompile it and use the code? Yes. But it's not, again, straightforward. As I say, they start obfuscating things, and it's not simple. It's not a simple task to do it. And people who usually do this, they want some profit in return. So when you find all these third-party apps on torrents or somewhere off the web that, look, this is a cracked version, it might have an added extra source, which is usually a malware spying on you as well. Okay, so you can do that, but the question is, should you, or is it's totally up to you? Why do you need it? And it's also probably a crime breaking it. Do you want me to talk about how do you disclose these vulnerabilities and how you need to be secure when you do this, the laws you need to be aware of it, or do you want me to talk about how to do that repackaging and stuff? Because repackaging is not straightforward and simple. So I think that is something which you should learn at a much later stage once all of you have made at least a single app. Since most of you haven't even made an app, it's not a good idea for you to know that. That's my only issue. If you have made an application, it's much simpler. It's straightforward. Because once you have the code, all you need to do is copy paste the code, and yeah, you got one more application. Okay, it's just, I mean, it's not that straightforward again, but once you understand how to make Android applications, you have the code of the other application as well, so it becomes easier. Okay, so I'll tell you this. Where do you learn more about this? How do you learn more about this? And how do you keep on learning about this? It's not like these things are gonna stay. So over the years, Android's app security system increased. Like if you look at the OS versions, Android 2.3 is more vulnerable than 4.0, which is in turn more vulnerable than 5.2. These vulnerabilities get fixed at the OS level at each upgrade. When you're getting an upgrade, you also get security upgrades. On the fly, there are things which get upgrades. And this, what I spoke was specifically on app level, each app level, what it's doing. But when you look at the OS level, it's a much deeper game again. So if you understand the OS, once, if you're studying your OS systems at some point in time, you can understand, you can look at the entire Android OS source code, which is in public domain, and you can check what are the issues in it. And that's why it's very easy to find hacks, vulnerabilities in Android rather than an iPhone, because iOS is closed. You don't have the source code at all. That makes it very complicated as well. So easier access to code, you know that, okay, this function, this particular class and the Android OS needs to be doing this. Now, this is where I could probably perform an attack. So the good the best part of Android is it's open, you can learn, you can do whatever you want, but that's also a vulnerability sometimes. So if you want to learn more about this, if you really want to understand this, the first thing you need to do is move away from Windows. Okay? Please do that. It's not easy to do work on these things on a Windows machine because you don't have the tools which make it easier. It's really I mean, you can do it. It's not that you can support Windows, but it takes up a lot of time. It's really messy to set these things up, and whenever they upgrade, it breaks. So all the updates usually come to Macintosh first, then Linux, and at the end, then Windows at the last if it's developer tools, not your basic customer software like Photoshop or something. You won't find that for Linux. So there are a lot of communities in India where you can learn some of these stuff. So there's a community called Null. Null is basically a community of programmers, security testers. So they have an online mailing list. It's an open security community. They have chapters across India. They have a mailing list. They have a Chennai chapter also. I believe they're meeting on 18th. 18. Yeah, you can just go for these meetups. They'll talk about one new security issue every other meetup. They'll have speakers who would be talking about some of these stuff. You won't get it. Trust me, you won't get it the first time you go. But over the course, you will understand what's happening, provided you also keep on learning things. So Null is where the Gmail, they have a Gmail group or a mailing list. I think it's a Gmail group. Yeah, you just sign up here and you get a mailing list. You get a request for the mailing list. Plus, check them out. They also have a conference called NullCon, which happened in Goa like 2 weeks ago. It happens every year. You should go if after a year, once you have a good grasp of basic stuff, when you want to advance further. These security conferences are a good place to go. We also have a lot of other communities. We have something called Hill Hacks. This is not focused on, Hacks. So it's a community of hackers and makers. They're not necessarily hacking Android or web or something. Some of them are electrical engineers looking at hardware. Some of them are people, crafts who picking locks. Okay, so we're just communities of people in India who work on different stuff. So Hill Hacks is a good place if you want to learn about new hacking stuff, not necessarily in software. Like the way I was talking about, you can actually hack a road. You can start putting protected gateways for bicycles. You can start occupying the road. So you kind of have lots of different communities of people doing different kind of stuff, like building telescopes and stuff. Okay, so it's a mailing list. Also, they have a conference. It's usually in the hills. It's in Bir this year between May 15 and 31st. If you have summer holidays, please do come. Also, now the most important part. You know how to report bugs to private players using HackerOne or sending an email on Play Store. But what if it's a website? What if it's a third-party one? You will find some information somewhere on the website. If you do, send them a mail. If that's not the case, what if it's a government website? This is the most difficult part. You really can't get a government vulnerability fixed immediately. They work very slow. The way to report that is, the only way rather I know is, there is an institution called National Critical Information Infrastructure Center, Protection Center, sorry.
Yeah. So this is a national center where, so they also issue threat assessment. So they have newsletters where they talk about what vulnerabilities have been recently reported. Did Mozilla get any security issues here? The exploits which are reported. So they have a track of everything. They keep track of this and they publish them on newsletters, and they tell you the threat level. Is it serious? If it's serious, it's a red. If it's an average threat, it's usually orange. If it's normal, it's a small minor issue, it's in green. So you have the issues with iCloud, which happened with Apple in 2011. Okay, so they have these newsletters of different various happening things around the world. I don't think they publish anything about themselves. They don't do that. So, but they have these forms, okay, so where you tell them how to report stuff. They have guidelines for, so this is meant for state governments and other departments. So for example, somebody hacks IIT, the administrators need to file an instant report with some authority that we have been hacked. There is a structure in place. I'm not sure if it's being followed at anywhere in the country. I'm not really sure, but this is the only thing I know about them. So like, I file with them. If there is a security issue that I am aware of, I file with them. So there is an instant reporting if some sort of leakage happens and it got fixed. For example, you got hacked, you fixed it, you file that through instant reporting. Then there is vulnerability disclosure, which is an open bug, like the case with the Namo app where there was an issue, but you need to use these forms to file the application. Like, look, there is a vulnerability, and they'll fix it. It usually takes time, more than 1 to 2 months also, but governments do work a bit late. So malware is something I'll not get into. The sole focus on Android was basically to introduce you to the basic stuff at the basic level. Viruses and malwares are much more complicated, which you could pick up at a later stage once you're really comfortable with security. No, certain exists. So God only knows what certain does. Okay, but this is a new agency which was formed in 2014 or 15. So I heard they're better. At least I received a call from them once. So they're more receptive than certain. So when you file a report, right, a bug complaint, somebody needs to acknowledge that, okay, I received it, I'm going to check it out, and I'm going to reply back, I'm going to fix it. That doesn't happen with Amnon, unfortunately. I'm hoping things changes, but private players, they do acknowledge it. But sometimes they don't even give you any money. They will probably even file a threat that, look, you're not supposed to even start looking into our systems, which is wrong. They don't have any right to tell that. Whether it's ethically correct is a different question. Okay, so ethics is something, it's really complicated. It's just an opinion. Somebody else's opinion is somebody else. As long as you're not misusing it, you're not siphoning off money, you're not doing anything bad with it, it's okay. And you're just following that code of not publishing it in the public domain before reporting it to the right companies and authorities, you're okay to do this. The people in IIT Bombay who used to hack Domino's to get free food. So if you want to do some of this cool stuff, do once just to test it, but report it. And it's okay. I mean, you're in an academic environment where you're okay to be stupid. These are things you must do as a kid. So there's nothing wrong in doing that, but anything complicated, take a second opinion. You can always shoot me a mail. And also, when you're communicating over emails, there are various secure tools which you use. For example, there's something called PGP. Maybe we'll have a session on that sometime later. See, these are the various tools and various protocols, how you need to use cryptography, how you need to use encryption. These are stuff which you will learn over the course. It's not like you're going to learn it right now.
hopefully the WebOps Club will have some webinars or something on each topics individually over due course of time. And depending upon your skill sets too, we'll probably share a feedback form to understand what all programming languages do you know, what all protocols do you know, how much about encryption do you know. We really didn't do that before because we are trying to assess and gauge your skill sets first. But maybe we'll share that post this session, and depending on those feedbacks, your next sessions will be based on. And you can definitely request for some sessions. We'll try to get them arranged. Any questions? Are you guys happy you're here? Or was this good? I'm not really sure because depending upon, see, I plan my session based on the kind of people skill sets you had. And unfortunately, all of you are at like very introductory stage, which is okay, nothing bad about it, but spend some time on learning stuff. That's it. Yeah.
Let's say I'm making an app.
Sorry?
So let's say I'm making an Android app.
Yeah.
What are the things which I should take care to make sure that no one attacks the app or the application?
It's a tricky thing, right? Security is not it's not a one-way thing. It's not like, look, if you forget your password, I'm going to send you an SMS to reset it. I could even, what happens if the guy lost his cell phone and you're still sending this to old number? Some guy, the social engineering attacks, right? I steal your phone. I know your ID and password already. Or I don't know your password, I know your ID. All I do is use your ID, say that I forgot my password, send an SMS to my phone number, and I can easily do that. So it's not simply about your own app, that it's not entirely under your control. So you add in multiple layers. It's not that straightforward that you send him a message that once the moment he clicks forgot password. You check, you re-verify it at 2 to 3 stages. You ask him one set of PIN on his message, maybe the other set of his key from his email, or something else. Okay, so it's growing. It's not like the vulnerabilities are going to be the same. There is no direct answer to your question. You need to be aware of things as much as possible. That's why people and companies hire security experts to actually look after these things. Their job is to be familiar with every other new attack out there and make sure that your systems are not under threat. You need to constantly upgrade them. But the first time you release your app, it's definitely probably open to certain forms of attacks. Yes, any other questions?
Just go to the WebOps Club website. This is the address. And the first post itself, you can submit your feedback and your kind of marking your attendance. So you'll be given priority for next session. So you'll be getting invites first. Just give your feedback also.
So you know what all tools I kind of use today. You can go back, check what these tools are. They're supposed to do some basic simple stuff. Read how the web protocols work, read how DNS works, read how your request goes across multiple servers. So security doesn't always mean at the software layer. If this router is hacked, it has a Chinese manufacturing chip. If that is buggy, you're done. So that is one of the serious issues we face currently. So you need to be really familiar across a lot of these systems. So yeah, probably next session you put something on privacy, PGP, Tor, and other stuff, Facebook.
So the idea is that in order to analyze security or in order to look into the security of other applications, you need to be aware of how to build these applications. Whenever you build something, you will know how to break it. So at that point only you will get a very clear idea or a very holistic idea about all these security analysis or any of the tools that are. So I encourage all of you to build stuff, build websites, build apps. Then only you will be able to analyze them and understand what's wrong with them. So fix the security first in the first place.
So if you want to know my reason to learn all of this, I just wanted to find out where my bus was. As simple as it. Okay. So there are a lot of applications which publish real-time locations of buses and auto rickshaws. Okay. So there is this app in Delhi which does it. It uses encryption, but it does publish real-time information of buses. So I use their app. I kind of cracked it, and I use that data. This data is something which needs to be public, which I kind of believe it needs to be public. It's just bus information. It's good for the society that somebody knows where a bus is. More people will use the bus, less traffic. So that's what got me to learn the kind of stuff I'm doing. So it's basically on why you need it. If you're really trying to become a security engineer, please only learn about that.